નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Hello students, today we will study one of the topic of standard 9, chapter number 1, number systems. So, this is the topic of exercise 1.3, question number 1. So, in previous classes, we have studied about the what kind of decimal expansion the rational number has. So there are two types of decimal expansions. One is terminating and second one is non-terminating decimal expansions. And what kind of decimal expansions the irrational number has? Irrational number has non-terminating, non-recurring decimal expansions. So what is the question? And question number 1. Question number 1 is here given sum of the rational numbers and we have to identify that what kind of decimal expansions each of has. Right? So we will start with the first sub question. Question number 1, sub question number 1. So the given number is 36 upon 100. So we know that if we divide 36 with 100, we find the answer as 0.36, right? Or simply, as there is a denominator is 100, we can apply the decimal point, then it will give the answer 0.36. Okay. Question number 2. Question number 2 is, sub question number 2 is 1 upon 11, right? So here the decimal expansion of 1 upon 11 is, if we divide 1 with 11, what we will get here? Answer is equals to 0.09 bar. There is a bar on the 09. That means the pattern of the 09, that means 2 digit repeating itself. So what will be the answer here is 0.09090909 up to the infinite. That means this 2 digit repeats itself. That is why there is a bar on 2 digit 09, right? So the decimal expansions of this number is, we know that, terminating here, right? Because after 36 there is no digit and the remainder becomes 0 when we divide 36 with 100. While in this case the remainder never becomes 0 and this pattern continues, right? So this is the case of non-terminating decimal expansions, right? Third one is, here the mixed number is given, right? 4 1 upon 8. So if we convert it into the fraction form, what we will get? 8 4s are 32 plus 1 33, 33 upon 8. And if we divide 33 with 8, we will get the answer 4.125. Or simply, here we can see that 4 is there, yes. And if we divide 1 with 8, we will get 0.125. And adding 4 and 0.125, we will get the answer 4.125. So now you can say that here the decimal expansion stops. That means the remainder becomes 0. So this number has again the terminating decimal expansion. Now this is the fourth one, 3 upon 13. If we divide 3 upon 13, what we will get? We will get here 0.230769. And you can see that there is a bar on this 6 digit, right? That means the 6 digit repeats itself. So now you know that by dividing 3 upon 13, we never get the remainder as 0 and this decimal expansions is non-terminating decimal expansion, right? Fifth one is 2 upon 11. Again by dividing 2 upon 11, we will get the answer 0.18 bar. So whenever there is a bar on the digits in the decimal expansions, now we can say that it has non-terminating repeating decimal expansions, right? And the sixth one, last one is 329 upon 400. So by dividing 329 by 400, we will get the answer 0.8225. Here the remainder becomes 0. That is why it has terminating decimal expansions. So this first one, third one and sixth one has terminating decimal expansions, and second one, fourth one and fifth one has non-terminating repeating decimal expansions. We can also say there is non-terminating recurring, right? So this is the answer of question number 1. Now we will learn the question number 6. You may wonder why direct question number 6, because this question and this question are related. So what is the question? Question number 6. What is the question? See, the question number 6 is, look at several examples of rational numbers in the form p by q, where q is not equal to 0 and p and q are integers with no common factors other than 1 and having terminating decimal representation or expansion. Can you guess what property q must satisfy? Here the question is for the q. And what is q? Q is the denominator. Because we know that the rational numbers are in the form of numerator and denominator. And we represent, or in general form, we write down it as p upon q form. So q is our denominator, right? So here in the question we have asked that look at the several examples of the decimal form which has terminating decimal form. So here we know that this first one, third one and sixth one has terminating decimal expansions. Yes. So 3 examples here we have already. So now we have to find out what is the q, what property q has in these 3 cases. From that 3 cases we will conclude that what property q must satisfy such that the decimal expansion terminate, right? So see, now here in this first case, okay, also one thing given in the question is that whenever we take one of the example, the numerator and denominator should not have the factor other than 1. That means if numerator and denominator have any common factor, then first of all we have to cancel out that common factor. So in the first example, 36 upon 100. What is the common factor in 36 and 100? 4. Yes, 4 is the common factor. So 9 4s are 36 and 25 4s are 100. So if we cancel out the 4, what will remain with us is 25. So see, here is the table. I have make a table. Here this is the q. Q means the denominator. And what is the q here we find? That is 25. Why 25? Because 4 is the common factor and we cancel out each other. So what will remain us is 25. Now if we find out the prime factors of this 25, what we will get? 25 is 5 5s are 25. That means is equals to 5 raised to power 2. Right? Second one is here. Here we get 33 upon 8. Right? So 33 and 8 has no common factor other than 1. So we directly take 8. So our q in for this case is 8. Q means the denominator. Prime factors of this 8 is 2 multiplied by 2 multiplied by 2. That means 2 raised to power 3. Third example is of 329 upon 400. Again there is no common factor in 329 and 400. So for this case our q, the denominator is as it is 400. And the prime factors of this 400 is 2 into 2 into 2 into 2 into 5 into 5. 2 to the 4 to the 8 to the 16, 16 5s are 80, 18 5s are 400. So we will get 2 raised to power 1, 2, 3, 4 multiplied by 5 raised to power 2. So by these 3 examples, we can conclude that the rational number which has terminating decimal expansions their q, that means the denominator, is either in the form of 2 raised to m or 5 raised to n or 2 raised to m multiplied by 5 raised to n. Now what is m and n? Where m and n are positive integers, right? So now we will compare with this. See, this is the first case, 36 upon 100. By cancel out the common factor, we get the q as 25, and the prime factors of 25 is 5 raised to 2. That means it is this type of 2 raised to m, right? So this means it has a terminating decimal expansion. Second one is this. Again 8. 8 is again 2 raised to power 3. Sorry, this 5 raised to 2 is the case of 5 raised to n. Right? Now this 8 is 2 raised to power 3. That means it is in the form of 2 raised to m. Right? Third one is 400, which is this case. The denominator is q and q is 400. Its decimal prime factors are 2 raised to 4 into 5 raised to 2. And this is the form of this 2 raised to m into 5 raised to power n. Right? So whenever there is the denominator and the prime factorization of the denominator is either of the form 2 raised to m or 5 raised to n or 2 raised to m multiplied by 5 raised to n, then that type of rational numbers has terminating decimal expansions, right? So you can write down for the question number 6, answer of the question number 6 as, if the rational number has the denominator is the prime factors of the denominator is either of the form this or this, it has terminating decimal expansions, right? So here you can see that this 11 has non-terminating decimal expansion and its prime factorization is not in the form of this or this or this. That is why it is non-terminating decimal expansions. Again, here the denominator is 13. It has not prime factorization in the form of either this or this or this. That is why it is also of the form of non-terminating decimal expansions, right? So now you understand this question and its answer, right? Okay. So this is all about this lecture. Okay. Thank you. Thank you for joining us.